Hi, everyone. Welcome to another lesson. We are going to get into section 8 of chapter 1. This is the last section of chapter 1. We have a test over the entire chapter coming up at the end of this week. That'll be the first large product grade of the year. Your quizzes from last Friday are in the grade book. Feel free to look those over. I will release the answers here shortly, and you can look over the questions and answers. And if you want to retake that or redo it, just let me know because that is always an option. So let's get into section 1.8. We're going to start graphing. So as a warm-up, let's talk about how to graph. So what do we know about a coordinate plane? So go ahead and pause this video, think about it, and see what you know about a coordinate plane. All right, so a coordinate plane has many components. So to begin, we have 4 quadrants. The top right is quadrant 1, top left is quadrant 2, quadrant 3, and quadrant 4 is the bottom right. So it kind of goes in a counterclockwise motion. The center is what we call the origin. The left and right dark black line, that is the x-axis. The up and down is the y-axis, where the x and y-axis meet. Again, that's called the origin. And then in the warm-up, it talks about an ordered pair. An ordered pair is any point on this graph. I'll make a point here in the first quadrant. Any point has the coordinate x, y. The first number tells me how I'm going to go left and right. The second number gives me an up and down component, x and y. So the number of that first blue dot I put there is 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right. So I counted 9 this way, and then 1, 2, 3, 4, 5, 6, 7, 8 up. So the coordinate would be 9, 8. I hope that's a review from middle school, kind of refresh your memory on graphing. And now we're going to tie this into what we did last week with equations. So let's start with an example here. So it says identify the ordered pairs, then identify the domain and the range. So I can do this in a very simple table. So let's make a table here for this first one. Let's go x, y, and let's just go point by point. So this first point has an x value of 1 and a y value of 3. The second point would be 2, 4. The third point is 3, 5. And the fourth point is 4, 6. So each one we're looking at the x values and the y values to get coordinates, ordered pairs. You could also write these with parentheses. I could write that 1, 3. It's the same thing. So what is the domain? The domain is your x values. The range is your y values. You could write those out. Typically, when you do a set, you use brackets. So if I wanted to write out the domain, I could go 1, 2, 3, 4 with those little squiggly brackets. I'm not going to get real particular on a test or quiz. They ask for the domain or the range. You guys can write those out however you want. Take a minute here. Try the second one on your own. Make a little table and just identify these 4 coordinates. All right, I'm going to go through the answers here. The first one has an x value of 0 and a y value, which is between 10 and 8, which means that's the value of 9, 1, 8, 2, 7, and 3, 6. The domain is my x values. The range is my y values. Remember, x, domain, input. Y, output is your range. So example 2, I want to graph this now. So they're giving me a function, an equation, y equals 2x. And they give me a list of domain. Domain is my x values. So I'm going to make a table. And I'm going to list my x values, 0, 1, 2, 3. And if I want to go across and make it a little neater, that's fine. Actually made it a little messier. So all I'm going to do is I'm going to put each of my x values in for y, exactly what you did on the last quiz. So I'm going to go through this a little quick here. So 2 times 0 is 0, 2 times 1 is 2, 2 times 2 is 4, and 2 times 3 is 6. I'm going to take these points to my graph here. 0, 0 is right at the origin. 1, 2, 2, 4, and 3, 6. I'm going to grab my line tool. It's a little tough to make lines, and I can connect those dots. And when I connect them, let me see if I can make this a little bit better. You can see that those points do make a line. A function with a x variable that's not squared should make a line the majority of the time. You did not need that line if you just want to graph the points. All right, same thing. Go ahead, pause this video. You guys try this one on your own. Go ahead and pause, make a table, start with that domain, plug them into the x values, use your calculator, take your time, and graph these 5 points, 5 coordinates. Ready? Go. All right, I'm going to go ahead and fill in this table. So the first step is being able to make a table. Everything in math this year is going to build. So this is what we did a few sections back, and it was on your quiz last week. It is a very, very basic skill in math is substituting in my domain. All right, I substitute my domain in for x to get my y values. I input x and I output y. It's like a little machine. Now let's graph those points. Let's see what it looks like. I'll do it in red. So -2, -5. If I did this correctly, it should make a line. So let's see if I did it right. And how about that? My 3 red dots make a nice vertical line. Well, diagonal line. All right, let's do a little matching here. So go ahead, take a minute. This is a little tougher, not going to lie. Take your time. Maybe make little tables off to the side and see if you can match up which of these goes with which graph. Which equation goes with which graph. This is going to take you a couple minutes. So pause this video, take your time, and see what you come up with. All right, so let's start with number 15. I'm going to show you how the work for this would go. So I have y equals 6x. And I look at my graphs here, and I'm looking at the various points. And I'm looking at my domain for all of these graphs down at the bottom. And the point 1 is one that is used for most of these graphs. If you look at the bottom of each of these, the number 1 here. All right, so I'm going to start with 1 and see if I can't get a match. So let's see, when x equals 1, y equals 6. So let's look for the point 1, 6. So it looks like this one, 1, 6, that looks like it could be 6. This one right here, that looks like that could be 6. I know B's out. I know E's out. 1, I know A's out. And I know D's out. So I have two options here that it could be either one. So let's go to point x equals 2. So when x equals 2, I plug it in for x, and I get y equals 12. So which one is 12? Well, that point right there looks like 212. That one looks just short of 12. So the answer to number 15 would be letter C. I'm going to erase this now so that we can do another one. So I would do a similar process for each of these, where you take the function and kind of guess and check. I erased my C. Let me put the C back in there. So 15 is C. So let's do another one here. Let's do number 16. Y equals 6x minus 1. Well, if x equals 1, 6 times 1 is 6. 6 minus 1 is 5. Guys, just put that in your calculator, and it'll give you the answer for you. So which one? We know C is already taken. So where is 1, 5? Well, it looks like that could be 1, 5. Not that one, not that one, not that one, not that one. So 1, 5, there's only one graph that makes sense. So for 16, I would have the letter F. You can go through and do the same thing for every one of these graphs. For number 17, I know it can't be C. I know it can't be F. If I put 1 in for X, I'm going to get 7. So where do I see 1, 7? The coordinate 1, 7 looks like letter E. For number 18, now I have a fraction. If I put 1 in for X, I'm going to get 1/6 for Y. That doesn't really make sense. So I remember seeing one of these where I'm starting at different values. So use your calculator. If you put 6, I'm looking at letter B, 6 in for X, you're going to get 1 out for Y, but that's the point 60, so it can't be B. This point right here looks like 6, 1 in letter D, so that answer is going to be D. Let's go ahead and clean this up a little bit. Now I have 2 left. The answer is not C, F, E, or D. I got 2 left here. 1 minus 6 is -5, so I have this point here, 6, 0. 6 minus 6 equals 0, so this 19 has to be B, and 20 is going to be A. This would be a question that would be something you could see on an ACT type of test. That is a next level question. So let that process. That's a really, really good question. We got one problem left here. This one is not nearly as difficult as the last one. I have a table. Bell's going off here. D dollars for H hours worked. I look at my graph here. I see H hours worked is my x-axis. My dollars is my y-axis. So let's just go ahead and graph these. Let me go back here. So can I graph the point 1 and 6.75? Sure. It's going to be about right there. 2 and 13.5 will be about right there. 3 and 20 will be about right there. 5 and 33 is going to be right there. And 8 and 54 is going to be way up high. So I graph those functions. You can see those are going to make pretty close to a straight line. And nothing really to it. That one was pretty easy. All right, so that was just a basic introduction to graphing. This material is going to get more difficult as we go on through the year. Our graphing is going to get more difficult. We're going to incorporate those nice graphing calculators you guys have and show you how you can graph on those to make your life a little bit easier. But for right now, we're going to have you do these by hand. Your homework tonight is that last page of that chapter 1 packet. Hopefully you've been keeping up. There are 8 pages in that packet, 1 for every section of chapter 1. Those are all going to be due tomorrow. If you are a virtual learner, you're going to upload that entire packet. If you did it on a separate sheet of paper, take a bunch of pictures. If you printed it, take a picture of the printed out. In person, I will check those in class tomorrow. So all 8 pages due tomorrow. If you need another packet, I will upload the entire blank packet into Polaris for you. So have a great rest of your day. Have a great evening. Our chapter test is the end of this week. And I appreciate you watching. Have a great night.